Azure Machine Learning, Azure ML, is a cloud-based service that enables data scientists and developers to build, deploy, and manage machine learning models. One of the key features of Azure ML is the ability to trigger jobs, which are tasks that execute machine learning workflows. These jobs can be triggered manually, on a schedule, or in response to events from other services like Azure DevOps or GitHub. This presentation will explore the various methods to trigger Azure ML jobs, focusing on integration with Azure DevOps and GitHub for continuous integration and continuous deployment, CI/CD pipelines. An Azure ML job is a unit of work that runs a machine learning task, such as training a model, scoring data, or performing data preprocessing. Jobs are defined using scripts and configuration files, and they run in a managed environment provided by Azure. Jobs can be run on different compute targets, including local machines, Azure VMs, and Azure Kubernetes Service, AKS. The flexibility of Azure ML jobs allows for scalable and reproducible machine learning workflows, making it easier to manage and automate the entire machine learning lifecycle. Before triggering an Azure ML job, you need to set up an Azure ML workspace. The workspace is a centralized place to manage all the resources and artifacts needed for machine learning, including datasets, experiments, models, and compute resources. To create a workspace, you can use the Azure portal, Azure CLI, or Azure SDK for Python. Once the workspace is set up, you can register datasets, create experiments, and configure compute targets, which are essential for running jobs. Compute targets are the resources on which Azure ML jobs run. These can be local machines, Azure VMs, or clusters managed by Azure Kubernetes Service, AKS. To create a compute target, you can use the Azure portal, Azure CLI, or Azure SDK for Python. Once created, you can configure the compute target with the necessary dependencies and environment settings required for your machine learning tasks. Proper configuration ensures that your jobs run efficiently and effectively, leveraging the appropriate resources for the task at hand. To define an Azure ML job, you need to create a script that specifies the machine learning task and a configuration file that outlines the job's settings, such as the compute target, environment, and input-output data. The script can be written in Python, R, or other supported languages. Once the job is defined, you can submit it to the Azure ML workspace using the Azure portal, Azure CLI, or Azure SDK for Python. The job will then be queued and executed on the specified compute target, with progress and results tracked in the workspace. Azure DevOps is a suite of development tools that support CI/CD pipelines. Integrating Azure ML with Azure DevOps allows you to automate the deployment and retraining of machine learning models. You can create pipelines that trigger Azure ML jobs in response to code changes, ensuring that your models are always up to date. This integration involves setting up service connections, defining pipeline tasks, and configuring triggers. By leveraging Azure DevOps, you can streamline the machine learning lifecycle and improve collaboration between data scientists and developers. To trigger Azure ML jobs from Azure DevOps, you need to set up service connections that allow Azure DevOps to communicate with your Azure ML workspace. This involves creating a service principal in Azure Active Directory and configuring it in Azure DevOps. The service principal acts as a security identity that grants Azure DevOps the necessary permissions to access and manage resources in your Azure ML workspace. Once the service connection is set up, you can use it in your pipelines to trigger Azure ML jobs. Pipeline tasks in Azure DevOps define the steps required to build, test, and deploy your machine learning models. To trigger an Azure ML job, you can add tasks that use the Azure CLI or Azure SDK for Python to submit jobs to your Azure ML workspace. These tasks can be configured to run scripts, upload datasets, and monitor job status. By defining these tasks in your pipeline, you can automate the entire process of training, evaluating, and deploying machine learning models, ensuring consistency and reproducibility. Triggers in Azure DevOps pipelines determine when the pipeline should run. You can configure triggers to run the pipeline in response to various events, such as code commits, pull requests, or scheduled intervals. To trigger an Azure ML job, you can set up triggers that respond to changes in your code repository, ensuring that your machine learning models are retrained and redeployed whenever the underlying code or data changes. This helps maintain the accuracy and relevance of your models over time. GitHub is a popular platform for version control and collaboration. Integrating Azure ML with GitHub allows you to trigger machine learning jobs in response to code changes, similar to Azure DevOps. This integration involves setting up GitHub Actions, which are workflows that automate tasks based on events in your GitHub repository. By using GitHub Actions, you can create workflows that trigger Azure ML jobs, enabling continuous integration and continuous deployment, CI/CD, for your machine learning projects. GitHub Actions are workflows defined in YAML files that automate tasks in response to events in your GitHub repository. To trigger Azure ML jobs, you can create GitHub Actions that use the Azure CLI or Azure SDK for Python to submit jobs to your Azure ML workspace. These actions can be configured to run scripts, upload datasets, and monitor job status. By setting up GitHub Actions, you can automate the process of training, evaluating, and deploying machine learning models, ensuring that your models are always up to date. Workflow files in GitHub. Actions define the steps required to build, test, and deploy your machine learning models. These files are written in YAML and specify the events that trigger the workflow, the jobs to be run, and the steps within each job. To trigger an Azure ML job, you can define steps that use the Azure CLI or Azure SDK for Python to submit jobs to your Azure ML workspace. By defining these workflows, you can automate the entire machine learning lifecycle, from data preprocessing to model deployment. Triggers in GitHub Actions determine when the workflow should run. You can configure triggers to run the workflow in response to various events, such as code pushes, pull requests, or scheduled intervals. To trigger an Azure ML job, you can set up triggers that respond to changes in your code repository, ensuring that your machine learning models are retrained and redeployed whenever the underlying code or data changes. This helps maintain the accuracy and relevance of your models over time. Once an Azure ML job is triggered, it's important to monitor its progress and manage its lifecycle. Azure ML provides tools for tracking job status, viewing logs, and managing job outputs. You can use the Azure Portal, Azure CLI, or Azure SDK for Python to monitor and manage your jobs. By keeping track of job performance and results, you can ensure that your machine learning workflows run smoothly and produce the desired outcomes. Effective monitoring and management are key to maintaining the reliability and efficiency of your machine learning processes. Integrating Azure ML with Azure DevOps or GitHub requires careful planning and execution. Best practices include setting up robust security measures, such as using service principals and managing permissions to protect your resources. Additionally, it's important to define clear and reproducible workflows, use version control for scripts and configuration files, and automate as much of the process as possible. By following these best practices, you can ensure that your machine learning models are deployed and retrained efficiently and securely. Triggering Azure ML jobs from Azure DevOps or GitHub enables seamless integration of machine learning workflows into CI/CD pipelines. This automation ensures that your models are always up to date and can adapt to changes in data and code. By setting up service connections, defining pipeline tasks, and configuring triggers, you can streamline the deployment and retraining process. As a next step, consider exploring advanced features of Azure ML, such as automated machine learning and model interpretability, to further enhance your machine learning projects.